Okay, this is a review of the Unit 12 study guide on statistics. Okay, so in this unit, you need to be able to find the mean, the median, the mode, the range, and the standard deviation for a set of data. And we are going to use our calculator for this. So you're going to need to get really familiar with the stat button, which is located right here. So every time you have a set of data, you're going to want to hit stat, and then you need to enter in the data. So you're going to go enter. You want to edit. So just stat edit. So I'm going to put all my data in, and after every point you hit enter. So I have got 22, enter, 58, 25, 28, 32, 41, 49, 48, 35, 38, 52, 21, and 29. So after you get all your data in, you're going to hit stat again. And this time you want to go over to calc. So use your toggle key, go to calc, and you want one var stat. So you'll hit enter, and then enter until you get this screen here. So your mean is where it says X bar up here. Your median, if you scroll down, says MED. It's not going to tell you mode. That's the one thing it's not going to tell you. Your range you'll get by doing max minus min, and then standard deviation is this right up here, the cursive looking O next to an X. Okay, so from looking at my data in my calculator, I can see that the mean, or the average of my data, is 36.8. And if I scroll down, my median is 35. My mode is the most often repeated. So I've got to visually look at the data and see what's the most often repeated number. So if I look at the set of data, it looks like, do I even have a mode? You don't always have a mode. So I've got 22, I don't see any other 22s, 58, 25, 28, 32. I don't think there is a mode on this one. Nothing repeats. So there is no mode. So none. Don't leave it blank though. Make sure you write none. My range is my max minus my min. So for my calculator, my max was 58. My min was 21. So my range is going to be 58 minus 21, or 37. And then my standard deviation, I need to scroll back up. And again, it's that kind of cursive looking O next to the X, and it tells me it's 11.6. Okay, let's try another one. So I have a new set of numbers, which means I need to go to stat, I need to go to edit, and before I enter numbers, I need to clear, not delete. So I'm going to use my toggle, go to L1, hit clear, enter. That will clear the entire column for me. So now I'm entering in my new data. I've got 97, 92, 95, 88, 91, 89, 92, 89, 85, 99, 97, 87, 85, and 98. Once I've hit all my data in, I hit stat again and go to calc. And then I want one var stat. So enter, enter, and there's my screen. So this time it tells me my mean. Remember, my mean is the X bar. My mean is 91.7. My median, actually let's write my standard deviation while I'm up here. My standard deviation is 4.6. So again, that's that kind of cursive looking O. If I go down, my median is 91.5. That's the middle number, 91.5. I'm going to have to get the mode by looking at the data myself, but my range is my max, which is 99, minus my min, which is 85. So 99 minus 85 is 14. All right, so let's now look at for the mode, the most often repeated number. So it looks like 97 repeats. So I've got 97 and 97. I also have 92 repeats, 92 and 92. I've got, let's see, it looks like 85 repeats, 85 and 85. And it also looks like 89 repeats. So I actually have 4 modes. I have 97, 92, 89, and 85, because all of those numbers repeat twice. So I can have more than one number for a mode, or I can have no numbers for a mode like I did on the first example. Okay, now box and whisker plots. So to do box and whisker plots, again, I see all this data, so I know I'm going to hit my stat button. I'm going to enter in my data, which means I've got to clear out my data first. So I go up to the top, hit clear enter, and now I'm going to enter everything in. So I've got 65, 66, 71, 75, 60, 61, 59, 63, 63, 62, 68, 67, 70, 72, 68, 68, 67, 71, 70, and 74. So again, after I've entered my data, I go to Stat Calc, and I want one-var stats. Now, for a box and whisker, there's 5 points I need, and they're all located in the bottom, so you need to scroll down. I need the min, the Q1, the median, the Q3, and the max. So these are my 3 points I need. So when I'm drawing my box and whisker, I've got a line. I think I'm probably going to scale this by maybe 5s. So I've got 55, 60, not going to be perfect, 65, 70, 75, 80, 85. Okay, so my minimum is 59. I'm going to put a dot there for now. I'm not going to draw my picture, but there's my min. My max is 75. There's my max. My Q1 is 63. I'm going to draw a little bit of a line there. My median is 67.5. That's about right there, another line. And my Q3 is 70.5. That's about right there. So that's my box. And then my max and min are my whiskers. So I'm going to draw a line connecting. So again, this was my min. This was 59. This was my Q1, which was 63. This was my median, my middle, 67.5. Kind of messy. Okay, oops, I didn't want to undo all of that. All right, so again, here's my, I'm going to make it look a little bit neater. All right, so here's my min, which was 59. Here's my Q1, which was 63. Q2, which is the median, 67.5. My Q3 is 70.5, and my max is 75. So that's my box and whisker. Those are the 5 points. You get them all directly from your calculator. All right, now if I'm given a box and whisker plot, and I want to know the interquartile range. Remember, the interquartile range is the box part. So I can see here it's 18 and here is 10. So my interquartile range is not the same as the range. My range is max minus min. My interquartile is Q3. So this is Q3 minus Q1, or the box. So my Q3 is here at 18. My Q1 is here at 10. So my interquartile range is 18 minus 10, or 8. The median is always the middle. It looks like right here, my line, the middle line right here is 15. And the number that represents the lower quartile, Q1, that's right here. So that's 10. Okay, Z-scores. Again, when I see a set of data, I know I'm going to need to put this in my calculator. So I'm going to hit Stat. I'm going to go to Edit to enter my data. I'm going to clear it by going up and doing Clear, Enter. And then I'm going to start putting in my points. So I've got 91, 98, 84, 86, 88, 92, 78, 72, 74, 86, 90, 92, 71, and 95. All right, so I'm going to hit my stat button again, go over to Calc, and enter for OneVer stats. Now, what I need for Z-score, this is my Z-score formula right here. Z equals X minus the mean over the standard deviation. So I need to pick out the mean and the standard deviation from my calculator. So for this set of data, remember that the mean is X bar, but for my formula, I'm not using X bar, I'm using this cursive U. So my mean is 85.5, and then my standard deviation from my calculator has the X next to it, but my standard deviation is 8.3. So if I want to know the Z-score of a student who got an 89, Z equals 89 is my X value, that's my data point, minus the mean, 85.5, divided by the standard deviation. So when I put that in my calculator, 89 minus 85.5 divided by 8, it's a point, 0.3. The answer that I get for this one is 0.42. That means the score is above average because it's a positive Z-score. And that makes sense because 89 is above 85.5. So the same thing, I use the same mean and the same standard deviation for this next one. Find the Z-score of a student who got a 78. So now I have my X is going to be 78, but my mean is still 85.5, and my standard deviation is still 8.3. When I put that in my calculator, 78 minus 85.5 divided by 8.3, I get negative 0.9. The negative indicates that it is below average, which, if you look at the numbers, that is below average. 78 is below 85.5. My last one, I used the same numbers. Different colors so maybe we can see better. My last one, find the Z-score of a student who got a 68. I've got Z equals 68 minus 85.5 divided by the standard deviation of 8.3. And when I do that one in my calculator, again, it's below average, so I know I'm going to get a negative. I get negative 2.10. So again, to do Z-scores, you need to put the data in your calculator and find your mean and standard deviation, and then just plug into the formula. Okay, using the following data set, how many data points would have a Z-score greater than negative 0.7? So again, the minute I see a data set with numbers, you should be hitting Stat, Edit, and getting that data in your calculator. So I've got 12, 13, 17, 23, 45, 57, 64, 75, and 84. Okay, so again, calc, one-var stats, gives me my mean and my standard deviation. So my mean for this problem, which is the x bar, is 43.3. My standard deviation is 26.4. So now this question is a little different. How many data points would have a z-score greater than negative 0.7? So remember your formula is z equals x minus the mean over the standard deviation. So this time they gave me the z. So I've got negative 0.7 is my z, and I don't know the x. So I've got x minus 43.3 is my mean, and my standard deviation is 26.4. So to solve this one, you could either set it up as a proportion, or you could take a look at this and say, okay, I know that this is x minus 43.3 divided by 26.4. So the opposite of dividing by 26.4 is multiplying by 26.4. So I'm going to multiply both sides by 26.4. So I get, on this side, let's see what we get. We get 26.4 times negative 0.7. That gives us on this side negative 18.48 equals x minus 43.3. So now I still need to get the x by itself. So I'm going to add 43.3 to both sides. Again. So again, add. Okay, so when I do that, when I add 43.3 to both sides, I get on this side negative 18.48 plus 43.3 equals, oops, that's not what I want to do, negative 18.48 plus 43.3 is 24.82. 24.82 is what my x equals. Now, I want to know how many had a z-score greater than negative 0.7. So really what I'm saying is I want it to be greater than that. So this would be really a greater than sign if I was greater than, greater than, greater than. So I'm looking for x values that are greater than 24.82. So if I go back to my data, I can see, okay, greater than 24, that's greater, 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 greater. So I have 1, 2, 3, 4, 5. So my answer is going to be 5 because it's asking how many have a z-score greater, and it's 5. 5 data points have a z-score greater than negative 0.7. Okay, comparing z-scores for multiple sets of data. At a certain college, the applicants who take the SAT have average scores of 950 and a standard deviation of 120. Applicants who take the ACT have a mean of 22 with a standard deviation of 4. So first of all, we need to realize that we have two different sets of data here. We have the SAT and we have the ACT. So if I do everything for the SAT, let's say okay, so everything for the SAT I'm going to do in yellow. And this talks also about SAT down here. And let's maybe make everything for the ACT in blue. And then this is also an ACT down here. All right, so I'm going to need to find the scores for the Ryan on the SAT and Jeff on the ACT. So let's take a look. Let's do Ryan first. So Ryan's z-score is going to be his score of 1020 minus the mean for the SAT, which is 950, divided by the standard deviation for the SAT, which is 120. So Ryan's z-score is going to be 1020 minus 950 over 120, which is going to be 0.58. Now, Jeff's ACT score is going to be his score of 26 minus the average, which is 22, divided by the standard deviation, which is 4. So then Jeff's z-score is going to be 26 minus 22 over 4, which is 1. So if I want to know who did better, I'm looking at the bigger z-score. And the bigger z-score is this 1. So that means that Jeff did better. His z-score was higher. Okay. 4 classes held a fundraiser to go on their spring trip. Below is a list with 1 student from each class, the mean dollars raised for the class, standard deviation, and their personal z-score. Who made the least amount of money? Let's make this a little bit bigger. All right, so now I have basically this is mean. That's that. Standard deviation, and I have the z-scores. What I don't have are their actual amounts of money here. I don't have x. That would be the money. So we're going to find x for all of these. So again, we have to think about our formula here. My formula is z equals x minus the mean divided by the standard deviation. I have 3 pieces of data for each of these. I don't have the x. So for Rob, I have his z-score, which is 1.7. I don't know the amount of money he raised. I have his mean, which is 210, and I have his standard deviation, which is 42. And when I solve this equation for x, it turns out that Rob raised $281.40. So this is for Rob. Now, if I go to Jen, her z-score was negative 0.8. We don't know how much money she raised. The mean for her class was 340, and the standard deviation was 56. When I solve this one for x, I get that Jen made $295.20. Let's go to Trisha. All right. Trisha, her z-score was negative 1.2. We don't know how much she raised. Her mean was 290 for her class, and the standard deviation was 38. When I solve that one for x, it turns out that Trisha raised 244.40. And then my last one was Steve. So here's how much Steve made. Steve, his z-score was 2.5. I don't know how much he made. The mean was 150, and the standard deviation was 48. When I solve this one for x, I get that Steve raised 270. Okay, so when I compare these, now I can see really easily that I've got 281, I've got 295, 244, and 270. So the one who made the most money is Jen with 295. So quick refresher to you on how I solved these for x. I basically took the one, like for Rob, I took the 1.7 times 42 and then added 210. Jen's was negative 0.8 times 56 plus 340. Trisha's was negative 1.2 times 38 plus 290. And Steve's was 2.5 times 48 plus 150. Okay, line of best fit. Again, I have data. Whenever you see data, you're going to hit the stat button on your calculator and enter it in. So stat and then enter to get to edit. Now this time I have data that's going to go in L1 and L2. So remember that when I do my data for line of best fit, if it's on the top of a table or the left of a table, that's my X, which is my L1. And the bottom or the right of a table is my Y or my L2. So in L1, I'm going to put all the L1s in first. I've got 5, 10, 15, 20, 25, 30, 40, 50, and 60. And then I'm going to scroll over to L2 and put all my Y values in, 36, 34, 32, 30, 29, 28, 27, 26, and 25, and make sure they're equal. Make sure you don't have more in L1 than you have in L2. Go back to Stat, Calc. This time I'm not doing one var stat. I want a line of best fit, so I want the one that looks like line, number 4. I want to go to 4 and hit enter. Okay, so hit enter again. Gives me my A value and my B value, and I'm just going to plug them in. It tells me even the format to put them in for. It tells me AX plus B on my calculator, and it gives me the A and the B. So my equation is Y equals negative 0.19x plus 35.02. Now my next question, what's the wind chill at a speed of 100? Well, wind chill was Y and speed was X. So it's giving me an X and it wants a Y. So you're going to substitute that 100 for X. So I've got negative 0.19 times 100 plus 35.02. And when I substitute that, what I end up getting is 16.02. Okay, now curve of best fit. Again, when you see a bunch of data, you should hit your stat button and go to enter. I've got to clear out this data before I enter new data. So I'm going to put all my X's in L1 and all my Y's in L2. And the way I'm given this data, I'm given it as a set of points. But remember that points are X, Y, X, Y. So I could make this into a table, or I could just go through and put all my X values in and then all my Y values. All right, so I've got my X values are all the first ones. So let's actually highlight them. So these are my X values. Here, 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 and here. Those are all my X's. So I'm going to put those into L1. So I've got negative 8, negative 7, negative 6, negative 5, 3, 5, and 7. And then my Y values are all the other ones. So I've got 80.4, 57.8, 38.6, 22.8, 18.8, 51.8, and 98.4. Again, make sure they're even, that you have the same amount in L1 and L2. Go to Stat, Calc, and this time you want number 5, quadratic regression. This one's going to give you an A, a B, and a C, and you just, like the other ones, you just fill them in. So I've got Y equals, my A is 1.7, and that goes in front of the X squared. My B is 2.9, and that goes in front of the X. And my C is negative 5.2. So now it's asking me what is the expected output when the input is 1. So output would be y, input is x. So again, they're giving me an x and looking for a y. So I'm going to do 1.7, 1 squared plus 2.9 times 1 minus 5.2. And when I solve that and put it in my calculator, I get, and actually let's go over how to put this in your calculator. Because the easiest way to put this is to store the value of 1, to do 1 stow x, and then I can just enter in 1.7 x squared plus 2.9 x minus 5.2. It tells me that my y value is going to be negative 0.6. So when my input is 1, my output is negative 0.6. Okay, last type of question for the study guide. Determine whether the given data is linear or quadratic. So what you're basically looking here for are, does it follow a linear pattern of jumping by the same amount, having a slope? My y values have a similar jump up or a similar jump down. Quadratic means it's got big jumps, or it might start going down and then go back up. So if I look at this first one, my x's, I've got 4, 6, 7, 9. My x's are going up. My y's are also going up. So when I jump 2 for my x's, I'm jumping 7, 8, 9 here. When I jump 1 for my x's, I went actually down a little bit. I went down 4. When I jump 2 here, I'm going up 12. Here I'm jumping 2, I'm going down 3. Here I'm jumping 2, I'm going up 6. It's a little bit off because, again, our data is not perfect, right? That's why we do line of best fit and curve of best fit. But you can tell they're not huge, huge jumps. So this one, even though it's not perfect and my slopes are not all the same, it's pretty consistent. So this one is actually going to be linear. Okay, now this next one. All right, this next one here, if I look at my y values, my x's are going up by 1. My y values are going, it goes up by 40, goes up by 20, and then it starts going down. So the fact that it goes up by big jumps and then goes down by big jumps, this one is quadratic. And this third one, I'm going up by 30. And my y values jump hugely down here. My y goes down by thousands, and then but it goes down by less thousands, and then it only goes down by hundreds, and then it goes back up. So again, it's got big jumps down, big jumps up. It's quadratic. So this one also went up and down, but you notice the jumps were much smaller. So this one, 53 to 62, that's relatively small. 62 to 58, 58 to 70. We're talking much smaller jumps, and it's more consistent. These are huge jumps, and it's not consistent. 80 to 120, that's 40. 120 to 140 is 20. Then I go down by 5. Then I go from 135 to 75, which again is a huge jump, and 75 to 0 is a jump of 75. So just look for the huge jumps and look for going up and then back down, or down and then back up for quadratic.